This is section 1.3 and it is on linear functions, and here is your list of I can statements that you should be able to do once you're done with this section. The first thing that we're going to talk about is this question right here. What are some qualities linear functions have? And I have this famous y equals mx plus b equation, which is a linear function. And this is an example of what a linear function looks like. And notice how the variable x and y, in this case, and the variable t and s, and the variables p and a, notice how the variables only have a first power, and normally you don't write t to the first, you just write t. And also notice how the variables are not in one term, but they're separate terms. So an example of not something that's not a function would be something like y equals t squared or y equals xz, how the variables are not separated by a plus or minus sign. Let's take a look at these three. Are they linear? And A, I would say yes. Each variable has a first power only, and they are in separate terms. B, I would say yes, that is too. It can just have one variable. In this case, because the m is 0, this term, we lose this term. This here, y equals 5, ends up to be a horizontal line, which we'll learn about in a couple minutes here. And then the last one, I would have to say no, because x and y are not separate terms. It's one term. Find the slope, y-intercept, and graph. So in order to find the slope and the y-intercept, we have to have these equations in slope-intercept form. If they're not, they're already. Where m is the slope and b is the y-intercept for graphing. So the first one, I would say it's already in slope-intercept form. And I would say the slope is, and being that I'm going to graph these, I'm going to make the slope 3 over 1 as a fraction because I have my rise over run. I'm going to move through these pretty quick because this is something you should have learned in Algebra 1 and Algebra 2. And then the 9 is the b, or the y-intercept. And if I was going to graph that, I would be at 9, so 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'd put a point there. And then I'm going to go up 3, 1, 2, 3, and over 1. And I'm going to draw my second point. I only need 2 points for a line, so that's all you should have. And then I'm going to draw my line with arrows at the end through both those points. Next one, I need to get y by itself, so it's in this form right here. So I'm going to divide both sides by 5, and I would have y equals 2/5. Whenever you have an equation that doesn't have the other variable, like actually 2 and 3 do, it is going to be either horizontal or vertical. And how you know is this one here crosses the y-axis at 2/5. So here's my 2/5. And I'm going to cross the y-axis, so this is going to be horizontal at 2/5. This number 3 is going to cross the y-axis at -2. And there's my point for that one, for my line. Number 4, I have to change this into slope-intercept form, so I'm going to subtract 2x. And I end up with a -6y equals -2x plus 14. And then I'm going to divide everything by -6. I'm going to do everything individually. So I prefer you to do that. It's easier. You don't make as many mistakes when you simplify then. So that ends up to be y equals, and then this here is 1/3 simplified. And this here is minus 6 goes into 14 twice. And that's 12. And then I have 2 left over out of 6, or 1/3. And then I'm going to go ahead and graph that one. So I'm at -2 1/3. And I'm going to rise 1, and I'm going to run 3. So I'm going to rise 1 and run 3. That's my second point. Go ahead and draw your line, and I'm done with that one. So again, this is my rise over run. Last one is just one variable, so I know it's going to be horizontal or vertical, and it'll tell me by knowing which one I'm crossing over. So I'm crossing over the x-axis at 1. So it's going to be vertical. Okay, the next page here, find the slope of the line through those 2 points. So remember, slope is y2 minus y1 over x2 minus x1, or you could just say the change in y over the change in x. And it doesn't matter which one you pick as your y1 or your y2, doesn't really matter. I don't want you to get hung up on that. Just if you're going to start with one, you start with it on both the top and the bottom. So this is going to be 6 minus a -6, and then 4 minus 28. So that's going to be 12 over -24, which is -1/2. So there is my slope. Next one. Change in y over change in x. So that's going to be, here's my y's, -10 minus 4, and 8 minus 8. And on the top, I'm going to have -14 over 0. And if you have a 0 in the denominator, your slope is undefined. You can't have a 0 in the denominator. Thinking of an undefined slope also, which means it's a vertical line. Last one, change in y over change in x is 0 over -6, which ends up to be a 0 slope. Thinking of a 0 slope, that is a horizontal line, just so you are aware of that. Okay, so just taking a peek at this page here, this purplish line here has a negative slope. It's going downhill as it goes from left to right. This red line has a positive slope. And over here, this green line has undefined slope, and this purple line is a 0 slope. And then I want to go over one more thing here, the intercepts, x and y intercepts. So this here, where the curve crosses the axis, the x-axis in this case, you're going to have whatever that x is, and your y is always going to be 0. You're not going to go up or down. And the y-intercept, your x is going to be 0, and you're going to have wherever that y is. So notice on these intercepts how if I'm finding the x-intercept, I'm finding the x. The y is always 0. If I'm finding the y-intercept, I'm finding the y, and the x is always 0. What is an intercept? An intercept is the point where a curve crosses an axis, whether it's the x or the y-axis. So if I was going to find the x and y intercepts of the graph of the equation, then graph, you're not going to change this into slope-intercept form. So you will not do that. If you do that, you're going to lose all your points because I'm asking you to find it using the intercepts. So just like I did on the last screen, the x-intercept, I'm finding the x, and my y is 0. The y-intercept, I'm finding the y, and the x is 0. So all I'm doing then is taking this y, plugging it in there, that makes that whole term 0, and then I have 2x equals 12 left, or x equals 6. I do the same for the other one. This is the x, so when my x is 0, this whole term is 0, so I end up with, don't forget the negative in front of the 3. Negative 3x equals 12, or x equals negative 4. Divide by negative 3. So those are my two intercepts. So the only thing that I should be seeing on your graph, oops, are those intercepts. So 6, 0. And 0, negative 4. And then I'm going to draw my line through those two intercepts. Very different than the last screen where we were doing slope-intercept forms. I'm going to get back to this lone problem. This is another problem where I'm writing an equation of the line that passes through that point and has this slope. So if I had y equals mx plus b, I know that my x is negative 1. I know that my y is 5. And I know my m is 3/4. So if I just plug those in where they go, here's my x, here's my y, and here's my m. I'm just plugging those in. So I'm going to have 5 equals 3/4 times negative 1 plus b. So this ends up to be negative 3/4. And then I'm going to add 3/4 to both sides. That's going to make that 0. So b ends up to be 5 3/4. So once I have I already had my m. Now I have my b. Now I'm going to bring those together to write my equation. Y equals m x plus b. And there's my equation. The difference between the constant rate of change and slope. So they mean the exact same thing, but the slope will have the number part only, and the constant rate of change is going to be numbers and words. I'm going to give you an example. So if I had 4/1 as my slope, it could mean that for every 4 minutes, I traveled 1 mile. Because this could have been minutes, or minutes per mile. I know it's kind of opposite of what you're thinking, miles per minute, but you could write it this way if this is what you're looking for. So notice they're the same, except this is just the numbers and this is the words of it. And you'll get to that when you get into like story problems. Okay, let's go back to that bigger problem here and work through this balance problem. This is where we spend all of our energy in this class, is applying those basic things that you learned in Algebra 1 and Algebra 2. A business property is purchased with a promise to pay off a $60,000 loan plus interest. So between the interest and the loan, that makes up your $76,500. and you're going to make 60 monthly payments of $1,275 each. The amount of money Y remaining to be paid on this loan is reduced by this much each month. So, if I was going to do what does your X mean and what does your Y mean here? The X is the number of months paid, and the Y is the amount of money remaining. So I'm going to write that in here. Number of months paid, and the Y is the amount owed or the money remaining. Same thing, right? The amount of money remaining to be paid is the amount that you owe. So just so we know, that's my X and that's my Y. So I'm going to answer A, find the X and Y intercepts of the graph of this equation. So how do you do that? We just learned that really basically the X-intercept, I'm finding the X given Y is 0, and the Y-intercept, I'm given the X is 0, I'm finding Y on the Y-intercept. So if I was going to do that, and I were going to plug in a 0 for Y, so the Y is 0. I need to solve for X, so I'm going to move this 76,000 over, so negative 76,500 equals negative 1275 X, and then I'm going to divide by negative 1275. You're going to show this work, and X ends up to be 60. So I'm going to put the 60 right here. That is the X-intercept. In order to find the Y-intercept, I'm going to put a 0 in for X. So if I put a 0 here, it's pretty simple, right? This whole term here is 0, and I'm left with the 76,500. So those are my X and Y intercepts. This is the work I would show to get there. Interpret what the X and Y intercepts mean. So the X-intercept, if you think about what that means, where does it cross the X-axis? That would mean and I'm going to just quickly graph this for you. So my X and Y intercepts here, I want to just put it on here. So this is 60. And I'm going to put the other one up here, so that's going to be 76,500. Put a point here and a point here, and it wouldn't make sense you'd have a negative number. And remember, this is the number of months paid. I'm doing this before I answer B because it makes more sense when you're looking at the graph. And this is the amount owed. So what does it mean? What does the X-intercept mean? What does the 60 mean here? Well, wouldn't the 60 mean, the number of months to pay, the number of months you have to pay your loan back? The 60 right here, which is the X-intercept, means that you would have $0 at 60 months that you paid. So the number of months paid, you paid $60, you'd have 0 left that you would owe, because this number here is 60, 0. So this would be, oops, I'm going to write this up here, sorry. You owe $0 after 60 months. The Y-intercept up here would mean that you would have to owe $76,500 in the beginning, right? Which would be 0 months. You would owe $76,500. So you would owe $76,500 at 0 months. C. moving right along. How should the x and y be limited in the model so they make sense? So I would say the limits for the x, these are boundaries, so this would be like the Windows part of your calculator. The x would go from 0 to 60. It wouldn't make sense that it would go over 60 because then you owe nothing at that point. So it would go from 0 to 60. And the y would go from 0 to 76,500. Oops. I don't know what is going on with my pen here. Let me try that again. Let me just change the order. I had this wrong on here. So this would be, oh yeah, that's right, 0 to 60 and 0 to 76,500. Okay, moving right along. Sorry for that pen issue here. Use the intercepts to graph the equation, and we already did that right there. Find the slope of this line. Well, the slope is right here. And I would say the slope is negative 1,275, only the number part. F is the next one. How does the amount owed on the loan change as the number of months increase? So amount owed decreases by $1,275 per month. And what I just wrote here is really the rate of change. Because I took the slope and I made it into basically a sentence. All right. Here is your homework. So you have, these are the non-word problems and these are the word problems right there.